So section 8.1 is an introduction to conic sections. So conic sections are basically shapes that can be formed by slicing into a cone. So think about the different ways you can slice into a cone. So if you go straight across, then you're going to make a circle. Do you guys see these little cross sections? So this would be a circular shape. If you go at an angle, you make something called an ellipse. Some of you guys might have called that an oval when you were a kid. Right, so we have a circle, we have an ellipse. If we cut at more of an angle and then we cut off the bottom basically, then we make a parabola shape. And if we cut straight into a double cone, then you would make what's called a hyperbola. So this would be, it's basically like this. Kind of like two parabolas together, but they're not quite the same shape as a parabola. All right, so it says it's very simple to graph conic sections using an application on the computer called Grapher. So all of you guys have something on your computer called Grapher. However, it can be kind of difficult to graph these curves using graphing calculators, because if you remember when you guys use graphing calculators and you hit the y equals button, everything says y equals, right? Well, these aren't necessarily functions, so sometimes when you solve for y, you have that plus or minus thing going on. So you actually have to input two functions. So I'll show you what I mean by that. So it says solve each equation for y and then graph the equations on a graphing calculator. Sketch a rough graph below and graph each conic section. So if I use something called Grapher on your computer, and I put this in, I don't have to have y equals. So see how it comes up and it says y equals? Can you guys see that? I can actually delete that out, and I can put parentheses x minus 1. I do my little caret, so I use the button that looks like the little triangle pointing upwards, right? And then plus y plus 2, and then raised to the 2. And then, oops, equals 25. So I can put that in, and you guys can see the shape. Does this make sense? If you wanted to adjust your window, all you do is you click the arrows, so you can make it go like negative 10 to 10, right? And then you could make this one go negative 10 to 10, like that. This actually looks like it's a oval this way, but it's actually a circle. So I could do center, origin, or equalize axes is what I would want. And that makes it so each grid is actually a square, not a rectangle. So if I did that, does this make sense? Do you guys see this? So this is how you would use Grapher. So you guys can use Grapher every now and then if you're like, I don't know what this shape looks like. That's fine, but we need to get used to using your graphing calculators because you can't take Grapher, like your entire computer, into the SAT, right? So we need to know how to do this on calculators, not on computers. All right, so this first one says solve each equation for y. So if I'm going to put it into the graphing calculator, I need y equals. So think about how I would solve for y. So the first thing I'm going to do is I'm going to subtract this x minus 1 squared to the other side. So I'm going to have y plus 2 squared equals 25 minus parentheses x minus 1 squared. And don't overcomplicate things. You don't need to FOIL things out or anything. Yeah, so we want to solve for y, so first we have to get rid of that squared, right? So we're going to take the square root of both sides. And remember, when we take a square root, what do we write? Plus or minus, right? So I get y plus 2 equals plus or minus the square root of 25 minus x minus 1 squared. Many of you guys are still forgetting the plus or minus. A lot of people miss points on the test for that. And again, we still want to solve for y, so we're going to subtract the 2 over. I'm just going to sneak it in the front. So I'm going to have negative 2 plus or minus the square root of 25 minus parentheses x minus 1 squared. And you cannot take the square root of 25 and you can't take the square root of x minus 1 squared. Okay, so think about the example we talked about before. If you had 4 plus 9 under a square root, that's going to be the square root of 13. Do we agree? Is it the square root of 4, which is 2, plus square root of 9, which is 3? No, 2 plus 3 is 5. It's not square root of 13, right? Does this make sense? So it's kind of the opposite of that rule. Like if you had 2 plus 3 squared, we can't say that it's 4 plus 9. So if we had the square root of 4 plus 9, we can't say that it's 2 plus 3. Same idea. Oh, I missed you. All right, so there's a chair right here. Okay, you can kind of sneak in around this way. You're going to do a little acrobat, so we're going to judge you a few trips. So, all right, so we're going to put this into our function, or into our graphing calculator's two functions. Okay, so we're going to put in y1, which is negative 2 plus the square root of 25 minus x minus 1 squared. And we're going to put in y2, which is going to be negative 2 minus the square root of 25 minus x minus 1 squared. So we need to use both the plus and the minus. Okay, so get your calculators out. So let's test this. All right, so when we put in negative 2, we actually need the negative, which is down in the corner. So negative 2 plus second square root 25. Now we use the minus sign. Parenthesis x minus 1 parenthesis squared. And you can end the parenthesis that was inside the square root or not. Can you guys see? It's kind of hard to see the green on the screen, so I'm going to turn off the lights so you guys can see it. Okay, so you guys not have calculators? This is what the issue is. Remember, second semester, you need a calculator. You're not going to do well on the test without it. So you need a calculator. You need to purchase one. I don't know how to put it into yours, Chris.
Oh, no, I'm just touching.
All right, so the next one. So I'm going to do negative 2 minus second square root, and I'm going to do 25 minus parenthesis x minus 1 parenthesis square, and you can end that last parenthesis if you want to. Do you guys understand what I mean by end the parenthesis? When you hit the square root button, it automatically puts that parenthesis there, so that's ending it for the inside the square root. You don't need to do that very last one, but all right, and then we can hit graph. So when we hit graph, it's going to graph both parts of that. So when I hit graph, it does that part, and then it does that part. And the graphing calculator will show you this space in between the curves. There's actually not a space there. Okay, so what the calculator is trying to do is to show you that it's two separate functions. So it's showing you, okay, I did the top part, and okay, I did the bottom part. Those were the two things you inputted. It doesn't want to connect those because it doesn't want you to think that it's all together, which it does join together. All right, now the weird thing about this is it's on the standard zoom, so like negative 10 to 10 for x's and negative 10 to 10 for y's. But if you think about it, look at that viewing window. Isn't it longer this way than it is this way? Do you guys agree? Yeah, so if you do that negative 10 to 10, it does make it look like an oval shape. So what we can do is we can do zoom, and then see how it says z square? That makes all of your little grid marks squares. So hit zoom 5, and now it looks more like a circle. Make sense? Okay, it does connect. Yeah, cool.
Is there a way just to look at the equations and like determine if they're going to be a circle?
There is, and that's what this whole chapter is going to be about. So conic sections, we're going to learn what these equations look like. So things to notice about A is that we had both x was being squared and y was being squared. Do you guys see how it was x in parentheses, something squared, and then y was in parentheses with something, and then squared. Okay, so that's a good thing to notice. And then they had a plus in between them. Okay, so let's try the next one. So we're going to solve this next one for y. So I'm going to subtract my 4x squared over. And I'm going to divide by 9. So I have y squared equals 36 minus 4x squared all over 9. And then I'm going to take the square root. So I'm going to have y equals plus or minus the square root of 36 minus 4x squared all over 9. So we're going to put this in as two functions. So the first one's going to look like this. It's going to have a kind of like a plus in front of it. We don't write the plus though. So I'm going to do parenthesis. And then I'm going to do another parenthesis. 36 minus 4x raised to the 2 is what I'm going to put in. And then I'm going to do divided by 9 and then another parenthesis. So do you guys see how that's inputting it? So it's inputting the entire numerator in parentheses divided by the 9. And then these outer parentheses just mean that all of that's under a square root.
Why'd you do it?
Because the button on your calculator is like a little raised too. So I just put it in just like you would do on the calculator.
Oh, but you basically just say it's squared.
Yeah.
Because on mine,
Yeah, you could just do x squared too. So then the other one is going to be, instead of y2 is equal to positive square root, we're going to have y2 equals negative. And then 36 minus 4x raised to the 2 divided by 9. Oh, whoops, I forgot my parenthesis in there. Okay, so go ahead and do that on yours. So I'm going to clear those out that I had before. So second square root, it's where the x squared button is. And then I'm going to do another parenthesis, 36 minus 4x raised to the 2, or you could do this x squared button over here on the left. It will just do your squared though, not the x. And then divided by 9. And then we're going to do the same thing, but notice I'm using this negative out here. Okay, so there is a difference between the negative and the minus sign. So if you're reading it and you say negative square root of blah, 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 it's the negative sign. So I'm going to do negative and then square root of 36 minus 4x raised to the 2 divided by 9, like that. And then I hit graph. Oops. What did I forget? I did. Thank you. So if it says syntax, you're usually missing something. So I'm inserting. Did you guys see how I did that? I did second, and then above the delete button, it says insert. That saves you a lot of time. You don't have to clear things out. So I inserted that second parenthesis. Thanks, Becca. All right, so this one is actually called an ellipse. It looks kind of like a circle, but if you count how far it's going over to the right, 1, 2, 3 from the center, and to the left, 1, 2, 3 from the center, and it's going up 2 and down 2. So it's not perfectly square this time. Does that make sense? Like perfectly like round, I guess I should say, not square. Like it's not a perfect circle. Okay, so this is what we call an ellipse. I guess I didn't describe the important points on this last one. So this last one would be over 1, negative 2. Here's what the last one would have looked like. And then it would have a radius of 5. So it's a circle, but it had a radius of 5. So its center of that circle would have been 1, negative 2. We'll talk about where that number comes from. Where do you guys think the 1, negative 2 comes from? In the equation, do you see how it's x minus 1, so it goes right 1? And then y plus 2. It's going down 2, actually. All right, and then this other one, its center was now at 0, 0. Do you guys see how it's centered perfectly at the center? And it goes over 1, 2, 3, over 1, 2, 3, up 1, 2, down 1, 2. So those are kind of the important points there.
So you could do this without a calculator?
Yes, we're going to learn how to do it without a calculator. So this was an ellipse. This was a center. Yeah, where do you guys think the radius of 5 it comes from part A? Yeah, it's from that square root of the number on the end. Okay, you guys actually did equations of circles. You should have done it in geometry. Did you guys talk about geometry? Yeah. All right, so C, it says y equals negative 1/2 x squared. Any guesses on what this one's going to look like? We've graphed this before. It's going to be a parabola, a downwards parabola, right? So this one is already solved for y. So we could just go to our y equals, clear out both of those. And then we can do negative 1/2. So I don't care how you put negative 1/2 in. You can do negative 0.5 if you want to, or negative 1 divided by 2. And then if you put the x squared, it's not going to put it on the denominator. It actually does the negative 1/2 first and then multiplies by x squared. So then x raised to the 2. And then if you graph it, it does look like a downwards parabola. Its vertex is at 0, 0. And then this last one, let's see what it looks like. So if I solve this last one for y, I'm going to have y squared equals 16 plus 4x squared. I add that 4x squared over. And then I get y equals plus or minus the square root of 16 plus 4x squared. So I'm going to put it in as y1 equals square root of 16 plus 4x squared. So you'll need parentheses around that 16 plus 4x squared. And I'm going to put it in as y2 equals negative square root of 16 plus 4x squared. No. Can you guys close that door too, because it's going to be loud. All right, so I'm going to have second square root, and I'm going to do 16 plus 4x squared. And then I'm going to have negative second square root 16 plus 4x squared. You guys getting faster with typing things in? And then we're going to hit graph. Yep, this one's going to be hyperbola. Yep, hyperbole is the English word. Hyperbola is the math word. All right, so it looks like that. Okay, so where do you think each vertex is? It looks like 0, and then count up 1, 2, 3, 4. Do you guys see that? So 0, 4, and 0, negative 4. So it looks like that and that. Okay. So at the bottom it says a parabola is a single curve, while the hyperbola consists of two curves. A parabola will have only x squared or y squared. So notice a number in letter C, we had y, like y to the first equals x to the 2. But a hyperbola will have both of them. So every other conic section has both, has x squared and y squared. So we're going to have to be able to tell the difference between a circle and an ellipse. And we're going to have to tell the difference between a hyperbola and circle and ellipse. So all those three will have x squared and y squared. So looking at A, the thing that's different than B is the x squared and y squared on B had numbers in front of it. See how it has 4 and 9? A circle just had like a 1 here. Now, a circle could also have like a 4 and a 4. That would be okay, because we could divide the 4 over. So it's a little tricky. But it'd be like the same number would be in front of our x squared and our y squareds. Okay, and then a hyperbola. What do we think is different about the hyperbola? With our x squared and y squared on this side, and this we had x squared and y squared on this side. What do you think? What did you say? It has a minus in between. So the x squared and y squared, when they're subtracted from each other, that's going to be hyperbola. And the ones that are y squared minus x squared are going to be what we call a vertical hyperbola. So it's going to look like this. Do you guys see my hands? So like pointing upwards and downwards. But then the ones that are x squared minus a y squared are going to go this way. This makes sense. All right, so that's kind of an overview. So using our calculators, we're not going to do a ton of calculator stuff. We're going to learn how to do these by hand. But we're getting more familiar with this. Yeah.
So I got that the hyperbola was both x squared and y squared,
But there's a minus in between it.
But then the ellipse and the circle, they both have x squared and y squared.
But the ellipse is going to have like, see how it has like a 4x squared and a 9y squared? It's going to have different numbers in front of it. But the circle had like a 1 in front of both of those. So we'll do these, but this is just kind of the preview of all of it. All right, so conic sections are all defined by distances. So going way back to geometry, let's talk about the distance formula and the midpoint formula. Do you guys remember the distance formula? You have to memorize it. So the distance formula looks like the square root of x2 minus x1 squared plus y2 minus y1 squared. It comes from the Pythagorean theorem. That's all it is. Did you guys know that? If you sketch it out, so you don't have to draw this, but if you had a point here and a point here and you wanted to know the distance between them, you find this distance, which was the difference between your x's, x2 minus x1, and you find this distance, which is the difference between your y's, y2 minus y1, and you square both of them in order to get d squared. So Pythagorean theorem, the leg squared plus leg squared equals d squared. And instead of having d squared in our formula, we just take the square root of both sides. All right. So the midpoint formula. So the midpoint formula, I always say it's the average of the x's, average of the y's. So it's going to be taking our x values and adding them together and dividing by 2, and taking the y values and adding them together and dividing by 2. So it's the average of the x's and it's the average of the y's. So, you know, when we find the average of two numbers, like if I said, find the average of 20 and 24, you would add those two numbers together and divide by 2. You're like, oh, 20 plus 24 is 44. Divided by 2 gives 22. Makes sense. It's halfway in between those two numbers. So number 1. So find the midpoint of the line segment with endpoints of 5, -2, and 3, 7. So our midpoint we write as a point. Notice how I did parentheses and I put a comma in between it? We always do that for a midpoint. It's a point. So I'm going to add my x values together, so 5 plus 3 divided by 2. And I'm going to add my y values together, so -2 plus 7, and then divide by 2. So I get 8 divided by 2, and I get 5 divided by 2. So it's 4 and 2.5, or you can write 5 over 2. Okay, it should make sense. It's the number that's halfway between the x's and the number that's halfway between the y's. So between 5 and 3, doesn't it make sense that it's 4? Between -2 and 7, it's 2.5. Okay, so those are the easy ones. We just add them together, divide by 2. But sometimes they have kind of tricky questions. So it says find the other endpoint if one of the endpoints is -4, 7, and the midpoint is 2, 9. Sorry, I'm still getting over this cold. Okay, so here's one way to do it. So we set up our equation. So we say 2, 9, that's our midpoint, right, is equal to the average of the x's, so -4 plus x divided by 2. Because we're saying our other endpoint is x, y. And then 7 plus y divided by 2, like that. And then we set up 2 equations. So our first equation involves the -4 plus x over 2. What's it going to be equal to? And then what about so we set this one equal to this. What about the other equation? What's it going to come from? So 9 is equal to 7 plus y over 2. Okay. So now we solve for x and we solve for y. Yeah, there's an easier way to do it. Yeah. Multiply the 2 over. So we get -4 plus x is equal to 4. So we get x is equal to 8. And then multiply the 2 over, so I get 18 equals 7 plus y. So y is equal to 11. So that means our point was 8, 11. Okay, so that's the first way to do it. So that works. That's the way I did it for a long time, and then I was like, why do I do it this way? I feel like it's so much easier to do it this other way. So if you want to do the other way, that's fine. Here's the shortcut. So when you're given the midpoint, and you're given one of the endpoints but not the other endpoint, you can line them up. Okay, so one of our endpoints, I usually call them A and B, it doesn't matter. And then we have the midpoint in between it. Our midpoint is 2, 9. One of our endpoints was -4, 7. The other endpoint we don't know. So if the midpoint is directly in between the 2 x values, that means however much you move from A to get to the midpoint for our x values, we're going to move just that same amount to get to the other one. Okay, so if I'm going from a value of -4 for x to a value of 2, how much did I add to -4? Yeah, I added 6. Do you guys see that? So to go from -4 up to 2, I add 6. So then I just do it again. So what number should our x value be? 8, exactly. And then same thing with the other ones. So I'm going to add, to go from 7 to 9, I'm going to add 2. And then I'm going to add 2 again. And sometimes you're subtracting, sometimes you're not adding. So I'm going to get 11. Does it make sense? So I get 8, 11 in the end, which is the same answer as what I had before. Okay, much easier, right? Okay, so try this one. So it says find the other endpoint if one of the endpoints is 3, -9 and the midpoint is 10, -19. So line them up. Okay, so if I'm going from 3 to 10, how much did I add? 7. So add it again. What did you guys get? All right, same thing for the next one. So if I'm going from -9 to -19, tricky, what am I doing? Yeah, subtracting 10. Do it again. So your answer should be 17, -29. That's the other endpoint. Does that make sense? So whatever you do to one of the sets of x values,
So you got 17 on that bottom part of like adding the 7 to the 10.
Yep, so whatever you added to get from the 3 to 10, add again to get from the 10 to the other endpoint. It's basically because if you have 2 points and you're trying to find the midpoint between them, I don't know where the midpoint would be, somewhere around there, then however much you add this way, you're going to add this way. It doesn't look even, does it? And however much you add this way, you're going to add this way as well to get halfway between. So we're finding directly in between. All right, so distance formula. So it says find the distance between each pair of points. Leave as a simplified square root if necessary. So if you get something like the square root of 8, right, we're not going to leave it as square root of 8. We're going to simplify that square root and write 2 root 2, right? Remember how we simplify square roots? All right, so this first one. So we have our x1 and our y1, and we have our x2 and our y2. So my distance formula is going to be x2 minus x1, so 12 minus a -3 squared. And then y2 minus y1, so -3 minus 5 squared. So I get 12 minus a -3 is 12 plus 3. So I have 15 squared. And I have -8 squared. Okay, you can't just take the square root of each of those and be like, oh, 15 plus -8. Can't do that, right? So we're going to find those. So 15 squared is 225. And -8 times -8 is 64. So when we add those together, what do we get? 289? Does anybody know the square root of 289? Yep, it's 17. Good. Some of you guys are good with your perfect squares. Some of you guys don't know them. It's okay. You can always try it on your calculator. If it gives you a decimal, then simplify the square root. All right, so this next one, same idea. So we're going to do our x2 minus x1. So I'm going to have my 1.5 minus a -0.5, and I'm going to square it. Then I'm going to add it to 0 minus a -6 squared. So 1.5 plus 0.5 gives me 2. And 0 minus a -6 gives me 6. So I'm going to have 2 squared plus 6 squared. So I have 4 plus 36. So I get the square root of 40. Square root of 40 does not go evenly, right? But we can at least simplify that square root. So do you guys remember how to simplify? So it breaks into like a factor tree of like 4 and 10, right? And then 2, 2, 2, 5. So how do we simplify it? What's a big perfect square that goes into it? Not a big one, but what's a perfect square that goes into it? 4. So if I break it into the square root of 4 and the square root of 10, the square root of 4 is 2, right? So I get 2 root 10 would be my answer. So that's the distance, 2 root 10. All right, so the next one, same thing. So see if you guys can set it up. Did you guys get 16 plus 16, so square root of 32? And then how do you break that apart? Did you guys get that? I see a lot of confused looks. Oh my God. Okay. So square root of 32, what goes into it that's a perfect square? No. 4 does, but 4 doesn't make it big enough. So you can do it that way. You can say, oh, 4 and 8. And then you know 4 is 2, but then you still have a square root of 8. And Square root of 8 breaks down further, right? It breaks down to 2 root 2. So you'd have 2 times 2 root 2, so 4 root 2. So what's the biggest perfect square that goes into 32? 16. So if you knew from there and you were like, oh, I have 16 and I have 2, then the square root of 16 is 4, so it's 4 root 2. So you get there faster if you do it that way. And again, you guys can do your factor tree if that's the method that you guys like the best. All right, and then number 5, it says find the center and radius of a circle that has a diameter with endpoints of 5, 4, and 0, negative 8. Okay, so sketching this one out helps sometimes, especially when you guys are first learning these. It's hard to like visualize what's going on. So let's think about it. So we have endpoints at 5, 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. And then 0, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is the diameter of the circle. So we have some kind of circle going around here. Like that. It's hard to draw. Mine does look like an ellipse, yes. I need to work on my circle. All right, so let's figure out what we need to know. So we need to figure out the center and the radius. So how do I get the center of that circle? Find the midpoint, right? Does that make sense? Find the midpoint. So our center is equal to the midpoint. So our midpoint was going to be adding our x's together, dividing by 2, adding our y's together, dividing by 2. So it's 5 over 2, which is 2.5, and it's negative 8 over 2, which is negative 4. Not negative, yeah, negative, not negative 8, hang on, negative 4 over 2. So negative 2. So that's our center. And then check to see if it makes sense based on your picture. So if I have negative 2.5, or sorry, 2.5, comma, negative 2, that's right here. Does that make sense? Yeah, my picture's a little off, but I think it makes sense. Okay, so now how about the radius? Distance between what? The midpoint to one of the endpoints. Now, what if you weren't certain that you got your midpoint right? Yeah, that's usually what I recommend. So I never use like a result unless I have to use that, like a result that I've already found. I never use something that I've already found before, just in case. What if I messed up on that part? Then I'm going to mess up on this next part too. Right, so let's go ahead and find the diameter, which is going to be our distance between our two endpoints. So we had 5, 4, and 0, negative 8. So I'm going to have 0 minus 5 squared plus negative 8 minus 4 squared. So I get negative 5 squared, which is 25. And I have negative 12 squared, which is 144. So I get the square root of 169. Anybody know that one? 13, right? So what does that mean our radius is? Yeah, 6.5, right? You divide it in 2. All right, so those are our two answers. Does this make sense? Okay. So we're going to stop here.